Hello and welcome to a new rubber duck programming video. I am George and today we will make a function that returns the factorial of an integer. I will be writing the code and at the same time explain the reasoning behind my thought process. So, to get started, I will be coding in Java using the NetBeans IDE. So, let us begin. Create a new project as a Java application and I will name it Factorial. After creating the new project, I can see my main class over here. I can see my main class. Let's clean this up a bit. And here I have the main function, which I will call in a bit. Some background information first. Factorial is defined as the factorial of an integer is the product of all the integers from 1 until that said integer. So, for instance, the factorial of 1, represented as 1 exclamation mark, equals to 1. Factorial of 2 equals to 1 times 2, which of course is 2. Factorial of 3 equals 1 times 2 times 3, which of course is 6. So, if we can wrap this up a bit, the factorial of any n integer is equal to said n times the factorial of the previous integer, n minus 1. This is called a recursive definition of the function, and this is one of the approaches that we are going to use today. But first, let us use a more common approach. So, let us begin. I will make a public static integer factorial 1. So I will implement this function a number of times and the number will be called n. Now, of course, if I want to return a number, I should store it somewhere, so I will name the variable that will be returned as result. Now, at the end of the function, I will return the result. And in between, I will do some calculations. Now, what will those calculations be? I should begin from, it should be obviously a for loop for int I equals 0 to I less than n I plus plus. So this for loop tells me that I will repeat with the counter of I n times, and I will go from 0 inclusive to n non-inclusive, which means n minus 1, since in each iteration I will be increased by 1. This is one of the two only viable forms of the for loop. For me at least, I think there are only two ways you can write the for loop in the correct manner. The other one being for from I equals 1, I less than or equal to n, where n is the amount of times you want it repeated. So this does almost the same thing. It repeats a process, the block of code that follows it. Let's create the blocks. It repeats the blocks of code that come after the for loop, the for command. And in the first case, it will begin from 0 to n and go until n minus 1. And the second case, we begin at 1 up until n. I've seen many times people doing some very different and nasty, bad-looking for loops, which is something like n equals null or different than null, with very intricate and strange things or expressions inside the for loop, which other than being really easy to miss some bugs, it makes the for loop really hard to read and understand. I mean, the computer will understand it, but I'm not sure a human person will understand it easily. So when you want something like that, the best thing you could do is do a while loop. While. So while this thing, and if we had int I equals get something, so if you had something like this, you could write it in this exact same way, and it would be quite clear that the loop is not a fixed count, is not repeating in a fixed amount, it's not going to repeat by a fixed amount of time. It's going to be repeated as many times as it's needed until this expression becomes true. Oh, yes, until it becomes false. Pardon me, my mistake. So until this expression becomes false, both for and while continue to execute the block of code. So in this case, for the factorial, where we know the amount of repetitions needed, which is expressed in the n number, we only need a for loop instead of a while loop. And I would argue that this is the better form because I equals 1 and not 0. Why? Because I'm going to multiply the result by the amount of I. So in the first go around, in the first repetition, result, which is initialized as 1, will be multiplied by 1, then it will be multiplied by 2, and then by 3, and then by 4, up until the point that it reaches n. For instance, if it's 3, as we saw before, it's going to be 1 times 2 times 3. And then it exits the for loop and returns the result. So, as you can see here, since when n equals 1, it's gonna do the operation 1 times 1, which means that we could easily write I equals 2, in which case this expression will be immediately false if n equals 1, and the return statement will give us 1, the initial value. But as I said before, it's much easier to read, even though it does one more useless multiplication. It's much easier to read and understand, and that's the whole thing about debugging. It's really important to understand the code easily and figure out the things that you original had in mind or the original programmer had in mind when reviewing the code at a later time. Since we only have one line of code, I would omit the brackets, and also this expression here can be written equivalently like this: result times equals I. So we assign to the result the same amount times the amount over here. Does it work well? Let's see. So I'm gonna try and do a for loop from 0 to 10. I think I didn't mention, but the factorial of 0 is defined as 1. So even if it doesn't get into this for loop, the result, the initial value, will be returned as 1. So system out print f percentage d exclamation mark equals percentage d, and the argument list is going to be I, comma, factorial 1 of I. So let's see if it works. Shift and F6. It takes some time. Oh, print F. I forgot to put the new line. And Shift F6. So it's 1, 1, 2, and 6 as we saw. So 3 factorial times 4 is 4 factorial. So 4 times 6 is 24, etc. I think it's correct. Now let's try a different approach. Of course, I could drive the point that I could write this even with less lines. So factorial 2 of n equals result equals 1. I don't need to put this over here. I just need put this from here over here. So if I write it like this, the result is going to be multiplied by I, and then I will be increased by an amount of 1. And there is no body in the for loop. It's empty, but I don't think it will matter much. So this should return the same thing, factorial 2, just as correct. And also I could even make it more even shorter. So instead of counting down I will count down n. So as n is larger than 1, instead of counting up, I will count down, n minus minus. So instead of going for the factorial of 6, calculating 1 times 2 times 3 times 4, it will calculate 6 times the previous one, times 5, times 4, times 3, times 1. Let's see if it works. And in fact it does, just like that. And just to make sure that I'm doing the right yeah, it's the right one. So it worked in the first time, and programmers are quite skeptical when their code works so easily. But it does work. I would argue though that Factorial 2 is a much worse code than Factorial 1, because 6 months from now I will read this code and immediately understand it, while this code I will go like, huh? What does this thing do? It's much harder to read and understand and figure out what it does than this one. Anyway, back to let's try a new approach. Public static int factorial 3. So the third approach is much easier. We will do it recursively. What's the recursive form? As I said before, the factorial of n can be defined also as the factorial of n minus 1, the factorial of n minus 1 times n. What does that mean? That I could return factorial 3 of n minus 1, n minus 1 times n. And of course, this recursion will never stop. It will reach 1, it will reach 0, and then minus 1. So I should fix that. So the first thing, don't do it like me. The first thing you do when writing a recursive function is the exit of the recursion. So if n is equal to 1, equal with two equal signs, if n equals 1, or in the case that it's equal to 0, just in case, equals 0, then return 1. So it will go into the recursion up until the point where there is no more recursion to do. We've reached the simplest case, which is 1 or 0 for that matter, and we are going to be returned 1, and then 1 times 2 after it returns to the second level, and the third level 2 times 3, etc., depending on how many times the factorial was called. So let's try it out. We will call factorial 3, and it works just like that. 1, 1, 2, 6, 24, 120, 720. What else can I do here? Not much apparently. So yeah, these were the 3 ways I can immediately think of while writing the factorial function. One is using a for loop, and the for loop in the proper way, in a way that is understandable and easy to modify and debug. The other one is just the freshman kind of code, the one who tries to write code with as little lines as possible, or with as little new variables as possible, thinking that having few lines or few variables, few repetitions, it's better for performance. But no, the performance in these cases is a non-issue. And lastly, the recursive function, which is just as understandable, and even I would argue it would be a bit more more easy to understand than the regular looping implementation of the code. In which cases we should better be careful not to lead our code into an infinite loop of recursions, an infinite recursion, and cause a Stack Overflow error. Oh, right. So how that would look? Let me remove the exit condition and see what happens in the case that something like this occurs. So we have an exception, a Stack Overflow error. We have called so many times the factorial 3 that we run out of stack memory, and Java complains about it. Anyway, that's it for now. These are the 3 implementations of the factorial functions. Thanks for keeping up with me, and I'll see you next time.